Hello, everyone. Welcome to this press conference on the new report, Meeting the China Challenge, a new American strategy for technology competition, produced by the 21st Century China Center, School of Global Policy and Strategy, UC San Diego, in cooperation with the Asia Society Center on U.S. China Relations. I'm Susan Shirk. I'm the chair of the 21st Century China Center and a research professor at GPS. And I want to give special welcome to the members of the media here today and also to our audience. Our webinar is recorded and will be available on video, which can be accessed later this week on our website, china.ucsd.edu. The report is already posted on our website. After our panelists' initial remarks introducing each section of the report, we'll open question and answer for members of the press first. If you're a reporter, please use the raise hand function on the bottom of your screen and you'll be unmuted to ask your question. And after we give the press the opportunity to ask questions, then we'll also be taking questions from the audience via the question and answer box. This report is the culmination of over a year of cross-sector study and thoughtful deliberation by the Working Group on Science and Technology in U.S. China Relations, which was established by the Task Force on U.S. China Policy that I co-chair with Orville Schell of the Asia Society. Our task force was seeing that science and technology had become a focal point of the increasingly competitive and contentious relations between the United States and China. So we decided to set up this bipartisan working group consisting of 28 members, scientists and technologists, as well as foreign policy and China experts. And the working group worked hard to achieve a consensus on a smart and effective American strategy that we could offer as a memo to the transition teams for the new administration. So I'd like to thank all the members of this group, also thank the Carnegie Corporation of New York that has provided generous support for the working group. We are launching this report at a critical juncture in American politics in order to set out some broad policy objectives as well as specific recommendations for the new administration covering 4 domains of science and technology: fundamental research, 5G, AI, and biotech. So why are we concerned about China's advances in science and technology? China has made great strides in innovation, and all that is a good thing. It's a testament to the ingenuity of the Chinese people and the fact that the Chinese government has made innovation such a important strategic objective. And of course, China's economic development and its scientific discoveries benefit people throughout the world. We don't want to block China's economic and technology progress, even though Chinese official media is telling the public that that is the main objective of the United States. But the United States does have 2 concerns. First, technology is an enabler of some of the worrying behaviors of the Chinese government, internationally as well as domestically. Domestic surveillance, the military buildup, and aggression toward its neighbors. But not only are we concerned about the way China behaves internationally and domestically, but we're also worried about the way China acquires its technological capabilities. It pursues a mercantilist, state-guided approach to creating national champions in frontier technology, protecting domestic firms from international competition, using massive subsidies, and sometimes using illicit methods to acquire technology from the US and other countries. This, in our view, is not fair competition. So these are the reasons that we see China as creating economic and security risks for the United States and other countries. And we believe that these risks require forceful collective responses. So now it's my pleasure to introduce to you my colleagues from the working group who will describe the findings and recommendations for each section. We'll start with Peter Cowie, who I'm very happy to say we persuaded to chair this working group. He is the Dean of the School of Global Policy and Strategy, veteran of the Clinton and Obama administrations. He'll introduce the approach and scope of the report and summarize some of our recommendations on 5G. And then he'll hand it over to Arthur Bienenstock, who is professor of photon science and former dean of research at Stanford University, emeritus professor. He will address fundamental scientific research, particularly at universities. Anya Manuel, co-founder and principal at Rice, Hadley, Gates, and Manuel, will also talk about fundamental science. Then Jason Metheny, who is the director of the Center for Security and Emerging Technology at Georgetown, will talk about artificial intelligence. And finally, Keith Yamamoto, professor and vice chancellor for science policy and strategy at UC San Francisco, will talk about biotech. So let me turn it over to our chair, Peter Cowie.
Well, thanks very much, Susan, and thank you all for joining us today. This report evolved a year of work from a group blending together expertise in science and technology, foreign policy, defense policy, and of course, the U.S. China Relations. We began with an investigation of what were some core bedrock facts from which we would develop our thinking. And we came to three conclusions that inform everything that follows. The first is that contrary to much of the discussion in Washington, D.C., the United States is in much better shape on leadership in the fundamental drivers of science and technology in the 21st century than many people believe. And because of that, the United States can craft a strategy starting from leadership, but then dealing with the fact that China is pressing hard to try to surpass the United States. The second conclusion we reached was that any sound strategy would have to focus on the long-term technology drivers for all of science and technology. A good example is semiconductor technology. That there were many short-term issues involving particular technologies and applications, but that a good strategy would be anchored on, as the saying goes, skating to where the puck is going, not where it is or where it's been in the past. And the third conclusion was simply that a radical divorce in the science and technology ecosystems of the United States and China was short-sighted, not easily achievable, and would be more costly than beneficial on balance. Now, from that starting point, we worked to craft some policy design principles that would inform all of the 4 case studies that Susan outlined to you. The first of those is, simply put, self-strengthening, or more colloquially, heal thyself. The ability of the United States to maintain its leadership in science and technology will primarily depend on actions that we are fully in control of, whether it's greater investment in research and development or fine-tuning and adjusting our advanced manufacturing capacities in the United States. The second principle is risk management. We should tighten and target risk management to focus on long-term issues driving the science and technology sector. The notion of risk management is really derived by analogy from the field of cybersecurity. We long ago learned that computer networks are invaluable and have to be broadly connected across the world. There is no such thing, however, as creating a foolproof firewall, a separation of those networks from people wishing ill action. And as a result, we have a strategy that partly tries for exclusion, consider passwords, but more actively depends on the fact that risks will emerge, and we should target where the most important risks are, build special protections around those, and then do active risk monitoring, have rapid response capabilities that are thought out in advance, and build some redundancy into systems so that if threats arise that are significant and lingering, we can start to substitute, as in supply chains, for example. And the third principle is simply that we should embrace international openness in science and technology. And we should do so in part because the United States asymmetrically benefits compared to China from that global openness. We are designed to benefit and thrive from openness. However, these three principles exist as complementary and deeply intertwined actions. Openness depends on improved risk management. Improved risk management is much easier to do if we are investing in our leadership in science and technology leadership. And science and technology leadership is much easier for us to sustain if we keep openness in the international science and technology system. Let me say a word about some of the thoughts in our report on 5G. And I invite you to take a look at the much more comprehensive view that we present in that report. Taking from the theory of skating to where the puck is going, we identify that the real long-term drivers of leadership and the keys to security in 5G are tied to the forces of semiconductor technology, cloud computing, and software. This may come as a surprise because the discussion in Washington is frequently about the early leadership of Huawei and radio access equipment. This leadership is real and it poses some real security issues. But the real advantage for the United States, both competitively and in dealing with security, is to foster an internet moment for the evolution of 5G. 5G now poses the possibility of creating a system where the next generation of international standards will open the door to a whole set of novel entrants into that competitive space. We use the internet analogy because what the internet did was create a set of open, transparent international standards for computer networking that broke the control and dominance of companies like IBM and NEC and created the companies like Cisco, Microsoft, and Intel as the true forces in global computer networking and information technology. The same thing can happen in 5G if the U.S. government, combined with industry, reasserts forceful leadership in the setting of evolving 5G standards, and we take complementary measures in R&D policies and other related issues to allow new entrants from the United States to enter the market. That will help us on the security side because this change in the configuration of 5G takes the control of the network over time away from the radio access equipment of Huawei to the computing and Internet of Things devices at the edge of the network. There are still measures we need to take in dealing with Huawei in the short term. But in the long term, the far bigger security risk is going to be tied to the fact that 5G is going to be enabling trillions of devices that we call the Internet of Things to operate at a global scale. And with that, many more actors, both national governments, cyber criminals, terrorists, will have the ability to disrupt this Internet of Things enabled by 5G. And that is where the risk management strategy really must focus in the long term while we deal with the particularities of Huawei in the short term. With that, I invite you to take a look at the longer report, and let me hand this over to my colleague, Arnie.
There are 5 points in the fundamental science section of the report that I want to stress. 1, it is vital that the U.S. remain a leader in fundamental research. With the U.S. only performing about 1/4 of the world's R&D, international collaboration is an important part of that. 2, China is by far the primary nation with which U.S. researchers collaborate. We must maintain those collaborations, particularly in areas of common concern like climate change and pandemics, the major threats to our national security. Even in the midst of the Cold War, U.S. and Soviet scientists were collaborating. I participated in one of those collaborations in the mid-1960s with the support of ARPA. 3, it is vital that the nation maintain a strong science and technology workforce, and graduate students from China are an important part of that. They earn about 1/4 of the advanced degrees awarded in computer science, engineering, mathematics, and the physical sciences, the fields that are so important in artificial intelligence, 5G, and quantum information, the designated industries of the future. Over 80% of them stay contributing to our nation's economy, health, and national security. We must keep them coming. We must never forget that students are the most important product of our nation's universities, not the intellectual property. 4, an essential part of the United States' strength in science and technology is the openness with which ideas flow. Particularly in our research universities, that openness yields better educated students and better research. It helps attract the best and the brightest from around the world. The costs of openness are smaller than the risks of a weakened workforce or declining quality of research. National Security Decision Directive 189, NSDD 189, promulgated by President Reagan and reconfirmed by Secretary of State Condoleezza Rice, codified that view with classification the mechanism for keeping sensitive research secret. 5, it is vital that the government increase its funding for fundamental research and the states increase their support of public higher education if we are to maintain scientific and technological leadership. The steady decline in the fraction of the GDP devoted to federal support of engineering and the physical sciences weakens us, while China is increasing its support in those areas. Similarly, the declining per capita funding of public higher education means greater student debt and less ability for those students to obtain advanced degrees in these fields and increases our dependence on immigrants. We cannot let these trends continue. Thank you, and now I hand off to Anu Emanuel.
Thanks, Artie. That was perfect. And Artie has just given you all the reasons why we believe it's so important that, especially in basic fundamental research, the kind that happens at universities and helps all of humanity increase its store of knowledge, we must keep collaborating with the world and also the Chinese. That's not to say there isn't a problem. We're not naive to this. Here in the Bay Area, there are lots of indictments of Chinese and others for stealing intellectual property. Some of that's happening at universities. Some of it's happening, of course, in businesses. So there is a real threat there. But we firmly believe, all of us on the working group, that instead of closing our borders to international collaboration, which would be disastrous, a sledgehammer approach, we use a risk management approach, as Peter already said. And let me give you just 4 points of how we believe that those risks could be appropriately managed. First, the government's visa vetting system has to be front and center here. Universities can't be responsible for this. They're just not equipped for it. And that doesn't mean don't give any visas to Chinese graduate students. It means train up people within the immigration service, within the FBI, to understand who's okay to come and who's not. So that's number one. Two, already mentioned it. Highly sensitive research in dual use areas should be classified and transferred from universities to national labs, where there is a far better infrastructure already in place to keep the things that need to be secret. So that's two. Three, openness requires honesty, integrity, transparency from all who are involved. We looked at some of the regulations that are in place at universities. They're there, but frankly, people have been a little bit naive and they haven't been consistently implemented. So universities should absolutely strengthen and rigorously implement all of their conflict of interest and their conflict of commitment policies and all of the vetting that happens in foreign funded projects. There's also a side point here that there's a bewildering number of entities in the US that's in charge of this. So maybe getting a bunch of key universities together and saying, here's best practices, and now we're all gonna move forward with this, would be an important step in the right direction. So that's three. Four, the universities need to do a little bit more here to train their own people. They should be regularly training their faculty and senior researchers to distinguish between appropriate and inappropriate collaborations, to explain what a conflict of interest is, to make them aware of the problem that does exist, but that we believe is manageable. Same, the flip side. They should be training both US and foreign researchers and students and saying, hey, if you're caught spying, you're going to be prosecuted to the full extent of the law, and that can include jail time. So just a little bit more openness and educating everyone about the rules that are already in place. And finally, like so many of the things we're talking about in this report with 5G, what Jason's going to talk about with AI and others, we can't do this alone. We have to cooperate with our friends and allies, whether it's Europe, Australia, others, and beyond, and make sure that they have similar risk mitigation protocols in place so that people aren't spying from their universities, because then it makes it harder for us to collaborate with them in turn. So those are just 4.5 points I would make that will preserve America's security and also ensure that our leadership in fundamental scientific research remains intact. And with that, I'll pass it off to Jason. Thanks, Jason.
Thanks, Anya. So I'm going to quickly cover some summary remarks about AI. As a level set, China has a national strategic objective to become a dominant leader in AI, but there's really only one area where China unambiguously leads, and that's in facial recognition, in part due to support from the government for applications related to social control, as well as commercial applications. And while it's frequently asserted that data is the new oil and China is the new Saudi Arabia, the importance of data as a strategic resource has been greatly exaggerated in the press. You just can't take mobile payments data, for example, and turn that into a system for recognizing objects in satellite imagery or a system for accelerating pharmaceutical discovery. Data just isn't a general purpose resource in this way. In contrast, talent in computer science and in math especially, and computing power built on semiconductors are general purpose resources. And the US has key structural advantages in both. We shouldn't rest on our laurels as we are engaged in a close competition in AI, but we should start by recognizing that we have asymmetric strengths. so that we can build competitive strategies that are more likely to succeed. The first strength for the U.S. is that we're very good at attracting global talent. No matter what country you were born in, most of the smartest people were born somewhere else. The U.S. has only 4% of the human population, and China has only 18%. 78% of the global population was born in neither country, and the U.S. has succeeded much more in attracting that talent to our economy. Over half of the mathematicians and computer scientists in Silicon Valley were born elsewhere, as were half of the co-founders of our billion-dollar tech startups. China hasn't been able to attract immigrants in large numbers, and even its own talent programs have had mixed success, as about 90% of China-born PhDs trained in the U.S. want to stay in the U.S. after graduation. Our open research system is part of what makes the U.S. an attractive destination, and as was described earlier, this is something we need to sustain wherever possible. A second advantage of the U.S. is our alliances. While China now spends more on research than the United States alone, collectively, the United States and its allies outspend China and its allies by 2 to 1. So the benefit of having friends in the world can really be extraordinary. A third advantage is semiconductors. Those are foundational to AI, with much of the recent advances in AI due to advances in computing. China imports $300 billion a year in semiconductors, more than it imports in oil, and its own efforts to expand semiconductor manufacturing have not proceeded well. The semiconductor supply chain has a significant bottleneck that's advantageous to the U.S. and our allies, and that 90% of semiconductor manufacturing equipment is produced by the U.S., Japan, and the Netherlands. And these countries so far have not yet shared with China the very most advanced equipment needed to produce leading-edge chips. Our recommendation for the U.S. is that, in the words of Jim Fallows, we should be more like us. We should double down on our asymmetric strengths to attract global talent, strengthen our alliances, and continue to invest in semiconductors. Concretely, we should double the National Security Foundation's funding for basic research in AI to a little under $2 billion per year. We should increase the National Institute of Standards and Technology's funding for AI testing, evaluation, verification, and validation by about $50 million per year, so that we enhance safety and privacy to bring our democratic allies on board with us. We should ensure that the U.S. and its allies lead in semiconductors by increasing R&D and advanced semiconductor manufacturing equipment and providing incentives for the construction of state-of-the-art manufacturing facilities in the U.S. We should also make sure that we provide controls on production technology that prevent the decoupling of semiconductor supply chains or semiconductor independence by China. Fourth, we should ensure that the U.S. remains the top destination for global talent by recruiting top students to U.S. universities and improving the immigration options available to all AI researchers and engineers, so including lifting numerical limits on H-1B visas and green cards for those working in AI fields. Fifth, we should mitigate risks of technology transfer through targeted countermeasures rather than using immigration bans, which are simply too blunt of an instrument. We should focus on increased prosecutorial resources for intellectual property theft, as well as improving intelligence resources for visa screening and post-entry review. Sixth and last, we should strengthen U.S. global leadership by drawing on our alliances with other democratic nations, emphasizing the AI standards process, which is one that we've ignored over the last few years, as well as the trade of technologies that are important for democratically aligned applications of AI, especially those that are privacy preserving, so that we bring our democratic allies with us. That's it for AI, and now I'll hand it off to Keith for the last set of remarks. Keith, over to you.
Great, Jason, thank you. The National Academy of Sciences, Engineering, and Medicine declared the 21st century to be the century of biology, where biotechnology innovations and solutions will address existential challenges for health, food, and environment, and energy. Biotechnology itself is a vast field encompassing at least four broad sectors: biosecurity and biodefense, digital biology and precision medicine, basic science and engineering, and the bioeconomy, which itself includes products and services spanning health, agriculture, energy, industrial products such as biochemicals, biomaterials, pharmaceutical reagents, and that sector itself accounts for nothing less than 5% of the U.S. gross domestic product on the order of $1 trillion a year. So the biotechnology subgroup recommendations align with the foundational principles and goals that were set out by Peter, that the whole working group embraces. And I'll summarize our subgroup's recommendations within that three-part framework. So the first goal is U.S. leadership. You've been hearing this from my colleagues. In the case of biotech, biotech originated in the United States 45 years ago, and we've been the global leader the entire time. However, our dominant position is threatened by decades of declining investment in science and technology R&D and education, and coupled with China's massive investment and focused commitment. So to maintain leadership, 4 actions. First, substantially increase federal investment in biotechnology-related science and technology R&D, notably in AI-aided precision medicine and synthetic biology, but across the sector. Second, mandate interagency coordination and collaboration for U.S. biotechnology and bioeconomy efforts. The U.S. Science and Technology Enterprise, the federal U.S. Enterprise, is fragmented across some 24 agencies and departments in the federal government with no coordination function. We think that OSTP could help to bring those efforts together in focused ways that would be substantially important. Third, strengthen support for STEM education and development of domestic talent in bioscience. Fourth, strengthen the U.S. innovation ecosystem for biotechnology. I'll say a bit more about that in a moment. So the second big goal that we heard from Peter and from my previous colleagues, manage risk. China's all-in effort in biotechnology clearly creates vulnerabilities and uncovers risks for both our research and production base. Again, here, 4 responses. First, capitalize on the U.S. leadership position to enunciate globally the imperatives for ethical science. That sounds like it's a big lift, but in fact, we're seeing success. We're seeing this successfully play out in the case of human genome editing using CRISPR technologies. U.S. really took the lead in pulling together an international consortium of scientists and government officials to begin to lay down worldwide guidelines using this technology. Second, require reciprocity as a condition for biomaterials exchange and data sharing with China. Third, develop effective countermeasures to China's programs that result in IP theft. You've heard a bit about that from previous colleagues. And fourth, diversify supply chains for pharma materials and products and medical equipment to reduce our dependence on China. And then the third big goal is to pursue openness. And again, you've heard a lot about this from my colleagues. As with the fundamental research group that we just heard, we found the benefits of cooperation and interdependence with China in biotech to vastly outweigh the risks to national security. So our group urges that risk mitigation and management, important, but it also be paired with openness. Already, the 2 countries appear to collaborate in biotech more with each other than with any other pair of countries in ways that appear to be mutually beneficial for both. The US and China have been leading in scientific publications related to COVID-19, despite the complicated and heightened tension between the 2 governments. China and the US have been publishing proportionally even more collaborative studies after the emergency of the pandemic than before. So clearly there are and would be huge benefits from US-China collaboration in biotechnology for addressing global, truly existential challenges facing our planet in health, environment, food, and energy. The moral and ethical implications and imperatives for making progress are urgent, and the science and technology opportunities are huge. Thus, it is really vital to maintain engagement. And with that, I'll stop and pass this back to Susan.
Well, thanks so much to my colleagues in the working group for your very succinct and forceful summaries of what's in our report. Of course, we hope that the audience will actually go and try to read at least part of the report in order to get more of the nuance and the detail, because one of our main conclusions is that you really need to dig deep into the nuance of the science and technology to think sensibly about what our policies should be. So our first question is from Jeffrey Mervis of Science Magazine.
Thank you. Can you hear me?
Yes, we can.
Okay, this report is billed as I wanted to know if there's any recommendations to President-elect Biden that you would like him, actions you would like him to take in the first 100 days, things that he could do unilaterally by executive order to advance these recommendations. And in a related question with regard to risk management, do you think that the current JCOR effort at OSTP is heading in the right direction, and do you support continuing that effort?
Okay, who would like to comment? Who's got a wish list of the first 100 days? Anya, did you want to say something?
First one of that, which is the first 100 days. And no, a lot of the things we recommend in all parts of this report are executive branch actions. Really, it's only the R&D, the increasing of R&D funding that requires a lot of congressional action. Some of the other things do too. But you could, for example, you heard across all the reports, we need better interagency coordination of what happens on science and technology and innovation. You could do that through the White House. That would be easy. You could do more on H-1B visas. You could do a lot on, we all recommended, you need a more sophisticated FBI prosecutorial force, immigration people. You just need to train up people to understand where the real problems are without overreaching. You can do all of that alone. And sort of 4 or 5 other ones that you see that are across all 5 of our reports that you could do pretty easily if you're willing in the first 100 days without Congress.
Susan, if I could add to
Yes.
this just a moment. One of the things that really emerged during this process across all the working groups was the importance of U.S. leadership in international standard setting, whether it's for reasons of security and competitiveness, like in 5G and how those standards emerge, or as you heard from Jason and Keith, our position in areas like AI applications and the use of new biomedical technology. So something that's very simple for the President-elect Biden to do is to instruct his team that in the first 100 days, they will show up at a very high level to the key international institutions like the International Telecommunication Union and all of its counterparts, and say that the U.S. is prepared to engage in a much deeper dive to accelerate progress in the right direction. And that is the first step, that type of international coordination that we talked about, at least among like-minded countries.
Jason, do you have anything you'd like, you share Peter's view on that? Anything else you'd like to say?
Just support for what both Anya and Peter said. I think those are exactly right.
Okay, great. Keith.
So, Jeff, I think one of the things that the new president can do is to reverse some of the actions of the old president. There is a proclamation that Trump signed back in May that bans entry of certain Chinese nationals on F or J visas. In April, the U.S. government, under Trump's orders, canceled a recently competitively renewed NIH grant that had in it a collaborative study with the Wuhan Institute of Virology that had just been reviewed with a very, very high score, and the grant was summarily canceled. There are a lot of other activities, withdrawal from the WHO. Trump took down the PCAST website and all of its reports. The ban human fetal tissue federal research back in 2019. So there's a raft of things that the Trump administration actions they have taken by executive order that could be reversed by executive order on day one.
Susan, if I may add just one other point, I think that it emerged across our various studies that we think that while there is a need for some new institutional arrangements internationally to deal with some of the coordination issues on regulation and security, that these are not incompatible with support and use of established international institutions. For example, the WTO. Places like the WTO are one venue, for example, for addressing issues of subsidies for Huawei sales at a massive level that has helped Huawei out. But there is compatibility between innovation in international institutions and preserving the strengths and benefits of existing ones.
Artie, you have thoughts on the OSTP part of the question?
I would urge OSTP to harmonize the conflict of interest and conflict of commitment rules across the agencies. Certainly when that was done with research misconduct, it clarified things for the universities. The other thing I would like to see the president do is reaffirm that NSDD 189 is national policy.
Great. Okay, next question from Adam Shu of Voice of America. Adam, you there?
Yes, I'm here. Can you hear me?
Yes.
My question was in line with the last one, raised by the other report. I was wondering, in regard to regarding to the U.S. actions with Chinese firm Huawei, do you think the Biden administration will reverse some of the policies, and more broadly, how the Biden administration will modify the Trump administration's China strategies with regard to the competition with China in technology?
Okay, well, let's start off with the more focused question about Huawei. Peter, would you like to answer that?
Sure. I don't see a reversal of the Trump administration's decision to ban Huawei as network equipment in the United States for 5G. That, I think, is a form of risk management that if particularly you're in a highly competitive relationship strategically with China, as the United States is, makes sense as an additional security measure. That's going to be joined and has been joined by a number of other countries. But the real challenge that the Biden administration is going to face is that a very large number of countries are not going to join that network ban. And then you need a consistent set of policies for dealing with the security risks that will exist because Huawei is distributed in equipment around the world on networks. And that network, those networks are sending traffic and data back and forth around the world. So there are numerous access points for security mischief. And that's why a broader risk management strategy about appropriate ways of dealing with the consequences of Huawei equipment being a fact of life in the global network will be sort of the next tune. But reversing the ban, I don't see being in the cards.
Okay, are there any other questions from the media right now? Any hands up? No, I don't think so. So,
Mitch Ambrose.
I'm sorry, what?
Hello, can you hear me?
Yes, Mitch Ambrose. Yes, what's your...
Yes, this is Mitch Ambrose from the American Institute of Physics. My question has to do with the recommendation around the small yard, high fence approach and identifying very specific dual-use fields to classify and then transfer from universities to national labs or other secure facilities. I was wondering if you could provide any specific examples of areas that are ripe for that type of review, and also the process by which that would be done. Do you have in mind an existing process like the Commerce Department's Emerging Technologies Export Control Review, or would this be a new interagency panel to make these types of decisions?
Artie or Anya, would you like to respond to that question?
Do you want to start and I can add?
Why don't you start, Anya?
Mitch, you know your subject well. This is really thorny, and we had discussions about it within our group because, of course, as you know, it's easy to say, high fence, small yard, but then what exactly goes in it? And, some of the tougher calls are how much of quantum computing? A lot of that is basic science, but some of it may be very strategically useful to the military once it gets a little farther along. AI and what Jason's group was doing, AI is an enormous field that covers so many different things. How do you sort out the things that are weapons-based versus not for something that's such a general use technology? So this is really hard. And I think your idea of using the existence Commerce Department review as a basis to look at this, because they're already looking at this carefully and they have people who are really steeped in the science, is maybe a good place to start. But I at least haven't heard of anyone who has thought this through in as much detail as needs to happen in the next few months.
I must say my own bias is towards the program officers, particularly in the most relevant agencies. They really know the individual projects, stay in touch by and large with the researchers, and could probably recommend a time for transfer to a more secure situation. But I know I tend to stand alone on that. Others don't seem to feel the same way.
I think that we should also note that in the report, you'll see a treatment of some possible criteria for what would constitute targets for this type of high fence treatment. If, for example, the United States does not have clear leadership in a dual-use technology of military relevance, then erecting the fence is probably too late already. And there are similar thoughts and examples worked out in the report.
Okay, great. Any other journalist questions? All right, well, let me move on then to...
there's one from Jody Klein from Southern China Morning Post.
Okay, great. South China Morning Post, yeah.
Hi, yeah. South China Morning Post from Hong Kong, based in New York. Thanks for having this important conversation. My question is whether you can help kind of break down the categories of the tech policies that have been put in place by the Trump administration, including Treasury-led CFIUS and FIRMA initiative and entity list and foundational tech list, as well as the emerging tech list and NDAA, and of course the executive orders that you already mentioned that could be rolled back somewhat. And most recently, the Clean Tech Network that also includes social media such as TikTok and WeChat. So in your view, which areas that the Biden administration might be able to roll back, and where would the line be drawn? Thank you.
Thank you. I think we'll let Peter make some speculations about that.
Right. Well, I think that first of all, we should be candid about the boundary lines for this report. We decided that we were going to try to come to some first principles, design principles, and we outlined them And then we decided to test them against digging into some specific areas of science and technology, the 4 case studies. In doing that, we have specific recommendations about ways of applying those principles to each of those technology fields. As we say in the preface of the report, we don't answer all the questions, and you've just given us a long list of questions that we didn't answer. But what we did do is say, this is the way to think through the types of questions that you're posing. So from that emerges both things where we would be perhaps more skeptical about some of the lists from the Trump administration, because it's not clear that limiting science and technology exchanges in fields that are not of high security relevance, or where the U.S. leadership in a particular application is not pertinent, should be restricted. But we also have identified some fields where we should pay closer attention. So I have to urge you to take a look at the case studies to understand the logic, rather than trying to give you a laundry list of answers.
And maybe I'll just add one point to Peter, which I think he's exactly right. Jody, you put your finger on a really important issue, which is that technology and innovation policy hasn't been coordinated very effectively across the US government. And that's not just a Trump administration problem. We just don't have the mechanisms to do it. OSTP is wonderful. They advise on tech policy, but they don't have the mandate to corral and push the interagency and sometimes bully the interagency. So that's why you're seeing Treasury doing something different from the executive orders, from what Commerce is doing, from a lot of stuff that State and Keith Crack and others are doing, and they're not very well coordinated. So that's a very difficult thing to get right. But I think it's something that a new Biden administration will start thinking carefully about.
Just to pile on with one last point, I totally agree with what both Anya and Peter said. And I think one other niche that we need to create within the federal government is a place for technology strategy, in which we think about long-term technology competition, move and counter move, sort of war game, what the likely reactions to U.S. policies are. We need something like the Office of Net Assessment that we've had for military strategy, but have it for technology strategy. And then we need to develop a cohort of technology strategists who see that as a professional track for themselves. We don't have that yet, but we need it.
Okay, well, let me, in the last 5 minutes, just give a couple of questions from the general audience that have been submitted, and ask our panelists to just give very quick answers to them. One question is about human rights, facial recognition, and surveillance, especially of Uyghurs in Xinjiang. So how can we make sure that our technologies are not being used for those purposes? Jason, there's some comments I know you make in the report, so I'll give you an opportunity.
Yeah, the first, very quickly, is just to understand what the computing systems that are used in Xinjiang are built on. And if they're being built on U.S. chips, then we should understand that. We should start instituting better end-use controls. Over.
Okay, and I think our report also notes that surveillance and repression is carried out through lots of different organizations and different methods in China, not all of which are cutting edge technologies. And so maybe rather than focusing on the technology, we should also focus on which individuals and which organizations are most responsible for the repressive measures. Okay, what about the question? There's a question here about how do we keep classified information confidential at the same time we collaborate with Chinese researchers? Can you talk a little bit more again about how we would especially handle that at universities? Anya?
Sure. I mean, Artie might want to start because he's done so much of it. But from what I understand, the way this is done at Stanford is a lot of people work both at a national lab, even Stanford researchers, and they do some of their research at Stanford. And if it becomes dual use or something related to the Defense Department, you take it to a national lab. But there are already methods in place for doing this. But Artie's done a lot of it throughout his career, so I'll let him take the lead.
I think the best example is how we university professors handle proprietary information that we get as consultants for companies. And that is, we keep those two realms completely separate. The tricky part, I think, is when to decide that something should go from the university to a national lab or a company that's prepared to deal with classified or proprietary research. And we don't have good mechanisms for that yet. And I think we have to work on those, but we should.
Okay.
But most of us handle proprietary information all the time, and there've been so few cases of problems.
Okay. One last question is about semiconductors, which is definitely a central question in the whole tech competition. The question is, what should the U.S. do with the advantage it now has in semiconductors? Should it try to stay ahead of China? Won't they catch up eventually? And should we even use our advantage to trade for something else on the Chinese side? Maybe Peter and Jason would have thoughts about that.
Well, I'll yield to Jason in just a second. I don't think we should trade that advantage against anything. This truly is a fundamental long-term driver, and it cuts across all of our cases. And it is also a technology where it's possible for us to maintain our leadership. Let me hand it over to Jason.
Okay, Jason.
I agree with Peter, and this was not an area that I had known well until a few years ago, and then you just see how foundational semiconductors are to the entire modern economy, and everything from AI to 5G to biotech ultimately depends on microprocessors. So really getting this right as a key choke point in our technology supply chain is essential. And I agree with Peter, we can maintain our leadership by continuing to make the investments in the next generation of semiconductor manufacturing and design. But we do need to increase our investment there. This is something that we're sort of letting go stale in our supply chain. Over.
Okay, great. Well, I'd like to thank our audience and thank all the panelists for being with us today. You can find the full report on our website. Please share it with your friends and colleagues. And if any of the press would like to follow up with interviews, please mail us. So thanks very much. This has been a really very educational experience for me. As a China scholar, I feel that I've learned a lot, and I've come away from the experience recognizing that just as foreign policy and area specialists had to learn a lot about nuclear technology during the Cold War, now those of us who want to contribute on how the U.S. should manage its relations with China really need to learn a lot more about these emerging technologies. So I want to thank my colleagues for being great teachers. I've learned a lot. Still have a long way to go, though. So thanks for joining us, everyone. Look forward to seeing you again soon at our 21st Century China Center events. Thank you. Bye-bye.